Hi everyone, welcome to this semester 2 SESI 2020 and 2021, and welcome to this Applied Thermodynamics. This is an advanced thermodynamics subject. Before you take this subject, make sure you already have taken your engineering thermodynamics last semester, yeah? So for this week, I'm your lecturer. I'm Dr. Pham Yan Yan. So for the first until the fourth week, so far we fix it as a video recorded lecture for all of you. I know that you have a very packed schedule for the first 4 weeks, um, especially for your lab. So we can still have some discussion. If you have any question, you still can WhatsApp me. We do have a WhatsApp group, right? So for this week, I'm going to introduce to you what is this course about, our meeting hour, our syllabus, reference books, what is sustainability in applied thermodynamics, why you as an engineer, we need to know about engineering thermodynamics. And we're going to review some of the fundamentals in thermodynamics, all right? Okay, so as I mentioned before, our lecture delivery methods is online. For those that you haven't joined the Apply Demo group, please scan the QR code here. Okay, so where you can get your notes and assignment. For your senior, we use WhatsApp and Smart V3, also Facebook. But this time, I think some of you suggest to me that we use Schoology, but unfortunately, I can't. And I think we can try to use Google Class. This is the code EEAX77G. Okay, once you log into the group, I'm still not familiar with the Google Class, so please bear with me. We learn it together. Uh, it should have some notification for you when is the note is ready. Yeah. So another way is you can also get your notes and your slides from Smart V3. I will upload in two sites. All right. Okay. So what about the attendance? The attendance link normally I will attach along for the session. So make sure you take all your attendance. Okay. This is your course outcome. So first, you're able to explain concisely about second law and how to apply in engineering application and how analyze and solve engineering problem related to heat engine and refrigeration cycle. You also will learn about gas and steam power engine. So you need to know how to differentiate them and how to apply, how to solve the problem. CO4 is able to relate sustainability to current issue in relation on thermodynamics engineering. That's why we need to know what is the sustainability means in thermodynamics later. So for this course, it will link with PO2, PO3, PO4, and PO7. Yeah, so the taxonomy will link, because this is an advanced course compared to engineering thermal, so we will have a higher taxonomy level compared to your engineering thermal. Okay, so this is, if you refer to the ESC manual 2020, so we are learning how to analyze the problem. So which link to WK1, WK2, WK3, and WK4. What are those? So it teach you on how you use the formula, how you use the basic knowledge to apply it and analyze. Okay, So design and development solution. Once you know some of the basic knowledge, okay, so for example, I give you engine and I might ask you to propose a way to improve the efficiency of the engine. So from there, you're able to achieve your PO3. So which link with WK5 knowledge that support engineering design in practice area. PO4, investigation. So you try to investigate what is the problem, how to analyze, what is the specification, how is the performance of the engine. So this link with the engage of selection knowledge in research literature review. So this will link with your assignment later, and also PO7 will link with your assignment, which is environment and sustainability. So you as an engineer, you need to make sure that your technology, your knowledge use is not harmful to the environment and also sustainable so that we can use it continuously in a good performance, yeah? So some of you, I'm not sure, some of you might not familiar about Bloom's taxonomy. Like in the this slide, I mentioned the taxonomy. So we link with CO3, 4, and 5, okay? 2, 3, 4, and 5, which means in this subject, you are going to deal with understanding, translating, summarizing, the basic one. And then after that, we will, once you have some knowledge, you are going to use the equation, how to apply your knowledge, how to design, how to calculate the performance, analysis. For example, I give you a chart, you analyze it, you tell me what happened to the cycle. A synthesis, using old concept create new idea. So for example, you know about the basic engine, all right? What about the latest development, right? You need to know the basic so that you can link with the latest development. Yeah, so this is synthesis is more to assignment, I would say. Okay, mark distribution evaluation system. So we will have only 3 ways to evaluate you. Test. Each chapter we have 1 test. Assignment. I will only give you individual assignment. Final exam will about, yeah, it will be 50% for your final exam. Okay, so the test assignment must be submitted at the specific time. If you failure to do so, yeah, you will get 0 unless you have a proof that you're not able to attend your assignment, your test. Okay, I think your senior always give an excuse that I couldn't submit because of the internet. I think normally I will give extra time on it. So in other way means you should have enough time to upload all your assignment and all your tests. So I don't think this is a rigid excuse anymore for this time, yeah? For the attendance. So for the attendance requirement, so for according to the ESC, your attendance should be more than, I think, at least 80 to 90%. If you're not able to achieve that, actually, you might have the risk to be banned to attend your final. So we don't want this happen. If possible, remember to click your attendance link. Make sure you click it, you attend to show your attendance, full attendance. Is that okay? Okay, so what am I going to learn throughout this semester? I would say engineering thermodynamics is quite challenging, but and yet very interesting. This semester, you are going to learn about entropy. What is the difference on entropy and enthalpy? Their name is quite similar, but totally two different things, which is very important in this subject. Some basic condition on engineering thermodynamics, for example, isothermic, adiabatic. You know the basic first, and then after that, we will learn about the ICE engine, which means you need to know about the inlet part of the engine. We will only touch petrol and diesel engine. We will learn about how they work, how to calculate the performance, what affect the performance, and also we learn about the gas power cycle, which is, this is a jet engine. So yeah, we are going to learn the jet engine. And after that, we are also going to learn about the steam power plant. This is very important as well, because when you go out there, doesn't mean that you are going to be just involved in automobile. You might going to join SESP to improve the efficiency, so that we don't need to enjoy the Earth hour almost every month. Yeah, and then we are all going to learn about refrigeration and air conditioning. I'm not sure your lecturer teach you about the psychometric chart. So in this part, we are going to learn about that. That's also one of the important one. Is that okay? So basically, this is a detailed syllabus. So for the first week is about introduction. The second week is about if this slide not able to cover for the first week, we will cover 2 weeks to touch about fundamental thermodynamics. Well, for your senior, I touch about entropy because the engineering thermodynamics lecturer not touching that at all. If your lecturer, I'm still collecting your survey. If your lecturer taught you that, then we might only spend a little bit of time on the fundamental, the equation, like I mentioned, isothermal, adiabatic, isochloric, all the condition, the equation. Once you score that well, you understand well, then it will be easier for the rest, okay? So then we go to the interesting chapter, which is ICE engine, that will explain about the petrol engine and the diesel engine. Then we will touch about the Brayton cycle, which is the gas power cycle. Brayton cycle actually is used as a jet engine. And after that, we will have a test. And we will touch about steam power plant. Probably if we have time, we will touch on the compressor, because compressor is also one of the important topic. And the last one is refrigeration cycle. Then we will have another test. I think, like I mentioned just now, each chapter I prefer to have a quiz or test. So that's depends on your survey. I'm still waiting for your survey, and again, yes, the test will take about 30%. So I think we are not only have 2 tests. We have at least, probably the minimum is 2 chapter per test. Yeah, I will make a survey form to get your opinion. So, and again, I think I would like to emphasize something, that is, this subject is not just myself give you some information, but in this case, we are learning together. So I hope that we have some feedback, although we have I can only show you the lecture, deliver the lecture through video recording. Okay? And sustainability issue, probably this might replace by the compressor that I mentioned. We will talk about that later. Okay, reference source. I think most of you have Chenko. If you don't have, get one. To be honest, I won't just stick on one textbook, but I think if you have this Chenko, it should be sufficient for you to at least cover part of it. And again, I won't just stick on one reference book. So if I'm able to get the link or the source, I will share with you guys. Is that okay? So what is the importance of thermodynamic for a mechanical engineer? So it's very common, like I mentioned to you, we learn about automobile cycle, how the Carnot cycle, Otto cycle, diesel cycle process. And we also learn about use that in refrigeration cycle. So, and mechanical engineer also work in power plant. So this involved is in ranking cycle, reheat regeneration, compressor. Also, you also need to learn that in heat transfer. Some of the university, they combine heat transfer and apply thermodynamics. In this part, we only focusing on the applied thermodynamics. Okay, what can we do with engineering and thermodynamic knowledge? Once you know the thermodynamic knowledge able to help you in increase the efficiency of the performance of a cycle of process. So you can improve it uh, and reduce the energy loss. Reuse and recycle of goods. Some of the waste heat, you can just reuse it to push up the performance of an heat exchanger or a cycle. Alternative fuel and power generation. Different fuel will deliver different performance and create different power energy. So when you know this basic knowledge, you're able to know all the things. And new green material design. Because okay, so when you know the thermodynamics, know the process, you know what you need for the process, you're able to find another green material, which is more look forward for the sustainable concept to make the things even more environmental friendly. Carbon sequestration, new green technology. Because of the thermodynamic, actually, for example, in Europe country, is gradually reduce use diesel in their car uh, because not because of the performance and also the carbon what's that the carbon the pollution. So when you know the thermodynamic knowledge, you're able to create, you're able to choose the right car. At least if you like car, you choose the right one to be more environmental friendly. So, and again, what is the importance of thermodynamic for a mechanical engineer? I'm sure until now you are quite clear. Yeah, you need all the basic knowledge so that you can help your future company save more money, high production. You as one of the responsibility citizen in this world to support, reuse, reduce, and recycle so that we can minimize the pollution in our world. Probably you can invent a new fuel for our car or vehicle, like Elon Musk. He created the Tesla car. So if I still have time, I will show you some of the Tesla car, share with you the Tesla car experience that I had in UK. So, all right. So we as an engineer, we need to know about sustainability, okay, in thermodynamics. So what is sustainability? There are so many definitions. It is in your reference, in your journal, in your newspaper, but until now, there's no specific definition on sustainability. Sustainability is to, I would say generally, is development that meets the needs of present without compromise the ability of future generation to meet their own needs. For example, if you use it now, but you create a lot of pollution which harm to the next generation, you're not doing something that's sustainable. Is the fuel that we are using, is that sustainable? What do you think? And the plastic, what do you think about that? Okay, so through the ESC manual, like I mentioned, we were going to link with PO7. So you need to understand and know how to evaluate the sustainability and impact professional engineering work. So for example, probably an assignment given, how you're going to deal with it. All right, this is one of the criteria you need to achieve before you graduate as a professional engineer. So, and again, you are an engineer. So, and sustainability actually touch three things. If you create something that good for environment, but it's very costly, and yet the end user not able to afford it, you fail, you're not able to achieve that. To achieve sustainability, you need to achieve environment, you need to make sure you achieve three things. Environmental, make sure you take good care of our environment. Social, okay, we give information, education, good standard of living, and economy. The technology that you're using is profitable and yet is not too costly to the end user. Sometimes, you know what is the difference between a scientist and engineer? Scientist is just want to make sure the process work done. But for engineer, you need to make sure that the process done, you will need to optimize it, and at the same time, you need to make sure the budget is low enough. So you need to make an adjust a balance on that. So that's a difference between an engineer and a scientist. So I think so far we stop here. Next week, we are going to touch about review of fundamental thermodynamics. We will go through on all the fundamental. This will just refresh your mind. What have you learned? What is zero law, first law? What is the fundamental? What is the, like this one? I'm not sure you learned this before, but this is very important. What is isothermal, adiabatic? What is the second law? And entropy. What is the difference between entropy and enthalpy? And we will touch a bit about your HS, your pH diagram, your TS diagram, how to read this kind of table. You need to know this in order to go to the next few chapters, all right? So I'm not going to touch that yet. So thank you everyone for your attention. I hope to see you next week.